channel Knowledge Hub. Friends, subscribe to the channel and click the bell icon for the latest updates. Today we're gonna start with the physics class 11, and that is your class is your 21. We had done your 20th class of the sessions in the last classes, and now today we'll start discussing about the unit 3rd, which is motion in a straight line. So that is unit 3rd, motion in a straight line, which we have to discuss here. On the same way, we had done your unit 1, which is your physical world, unit 2, which is units and measurement, and in motions in a straight line we even though had discussed rectilinear motions, retardation, negative acceleration, positive acceleration, constant uniform motion. All these we had discussed about it, even though we had discussed about the area under the VT curve that equal displacement of the object over a given time interval as well. Now today we're gonna start with another new topic, that is your kinematic equations for uniformly accelerated motion. But before starting with this, it's a huge request to all the viewers to please go ahead with like, share and subscribe, so that many and maximum people can get the information at once, and then you can also enjoy the video as well. Let's go for the same. Kinematic equations for uniformly accelerated motion. So kinematic equation for uniformly accelerated motion that we have to discuss here in the detail. In that, for uniformly accelerated motion, we can derive some simple equation that relate displacement x, time taken t, and initial velocity v naught, where final velocity v and acceleration a in that already obtained gives a relation between the final and the initial velocity v and v naught of an object moving with uniform acceleration a, and that will be v equals to v naught plus at. On your same way here, that v equals to u plus at, where this relation is a graphically that is represented here, and the area under this curve will be the area instant of O and T from 0 to T, and that area of triangle of ABC plus area of triangle OACD. So that will be finding it out. First I will draw that diagram so that it will be easy to you to understand as well. So here we go. So here this has been O, and here it will be the T. So here it will be the V. This has been the diagram here from A. It will go straight till point C. This is a constant one. This is uniform acceleration. So here we have a drop. I told you this is at T, and the point is D, where this is point B, we're at B. So here this is from B to C is V minus V naught till C. Okay, so and this is area under the VT curve for an object with uniform acceleration. So area under VT curve for on the same way. So here that is for an object with uniform acceleration. So here for the same, v equals to v naught plus 80 that we have here. So area between instants, area of area between ONT equals to area of triangle BC plus area of rectangle OACD, that is equals to half v minus v naught t plus v naught t. On the same way as explained in this previous section, that the area under the VT curve that represent the displacement, therefore the displacement of x of an object, that even though we had done in the last class, you will go for it if you had not visited that. Each and every class is very important, because each and every class contains a different topic and very important topic in terms of NCERT physics part 1 for class 11th. And this is also important for the competition one also, that those who are preparing for the competition, so this is very important for you all as well. So here for x equals to half v minus v naught t plus v naught t, v minus v naught equals to 80, therefore x equals to half 80 squared plus v naught t, x equals to v naught t plus half 80 square. So in that also we taken x equals to v plus v naught t by 2 equals to v bar t, where v bar equals to v plus v naught upon t2. This is a constant acceleration only. Here the equations of this, that mean that the object has undergone displacement x with an average velocity equals to the arithmetic average of the initial and the final velocity, where t equals to v minus v naught upon a, and simultaneously this is an equation we'll get here. X equals to vt equals to, here we that is we have our for that undergone equation, and for the same it will be vt is equals to v plus v naught by 2, v minus v naught by 2, v square minus v naught square upon 2a. So here v square equals to v naught square plus 2ax here. Now further we go for it and we will discuss the rest, and that is being the another important one of course. So the equation that can also be obtained by substituting the value of t from this into an equation. So thus we have obtained three important equation, and that is being important one. So I just write this is important equation, so I will just write it down by the highlight it. The first equation is v equals to v naught plus 80. This is very important. You understand in the further class, in the further sections or further topics, that why I have said that these were the very important. Another equation for the same will be x equals to v naught t plus half at square. This is also important. T, another one is v square equals to v naught square plus 2ax. This is also an important one. Here that connecting the 5 quantities v naught, v, a, t and x. These are kinematic equations of rectilinear motion for constant acceleration. On the same way that were obtained assuming that t equals to 0. So at t equals to 0, that the positions of the particle of x is 0. We can obtain a more general equation if we take the positions coordinate at t equals to 0 and as a non-zero. So say x naught, then they are modified replacing x by x minus naught, that x naught, and that to be, we will be evaluating v equals to v naught plus at, x is equals to x naught v naught t plus half at square. That's the same equations. And v square equals to v naught square plus 2a x minus x naught. This is what we have. Now, as I told you, these were the important equation. So we further continue the question. We will discuss the question third of the this unit. The two questions we had done in the last classes. So here we go. The question is, obtain equation of motion for constant acceleration using method of calculus. So for according to that only we will be doing, we will be using the calculus method. So here we go. Obtain equations of motion for constant acceleration using method of calculus that we have. So here we go for the solution here. By the definition, it will be a equals to dv by dt. Integrating both sides, we'll get, so here that is been dv equals to a dt, and by integrating this we'll get v from v naught dv equals to 0 to t a dt, which is equals to a 0 to t dt. This is a is constant here, so v minus v naught equals to at, v equals to v naught plus at. Further, v equals to dx by dt. Integrating both sides, here x from x naught dx equals to 0 to t v dt here. So for the same that we have in the same way, so that is equals to 0 to t v naught plus at dt here. So x minus x naught equals to v naught t plus half at square. X equals to x naught plus v naught t plus half at square. So we can write that. We can write a equals to dv by dt equals to dv by dx dx by dt equals to v dv by dx. Integrating both, or we can say v dv equals to a dx. Integrating both sides, what we'll get here? So for the same, it will be integrating both sides. So here we get v to v naught v du equals to x naught a dx. It will be v square minus v naught square upon 2 equals to a x minus x naught. So v square equals to v naught square plus 2a x minus x naught. So this is how that the advantages of this method is that it can be used for motions with non-uniform acceleration also. And now we shall use these equations to some important cases as well. Now we discuss another important question, that is the fourth question of the session, and that the question we have as follows. Question is, a ball is thrown vertically upward with a velocity of 20 meter second inverse from the top of the multi-story building. The height of the point from where the ball is thrown is 25 meter from the ground. So you have to find how high will the ball rise, and the B is how long will it be before the ball hits the ground. You have to take G equals to 10 meter seconds inverse square. So we find it out for the same here. Let's go for it. Fourth question of the session. So here we go. A ball is thrown vertically upward with a velocity of 20 meter second inverse from the top of multi-story building. Here, the height of the point from where the ball is thrown is 25 meter. The ball is thrown from where where the ball is thrown is 25 meter. From the ground. The first thing that we have to find out here, how high will the ball rise? and the b1 that we have to find out here. How long will it be before the ball hits the ground? Where we'll take g equals to 10 meters second inverse square. Now here for this we'll be solving it out, and for the first one we go here. Let us take the first, I will draw the diagram so that it will be helpful for you. So here it will be, this is the ground. Here this is 25 meter. So from here this is the point A, and that it will go up, that is B. And from that B point coming down. So this is the point here, from this y minus y naught till here, and then from here till the ground. Here it is y, and that will go A equals to minus 10 meter per second square. So for that, let us take the y-axis in the vertically upward direction with 0 at the ground as shown. So now we go for it. V naught equals to plus 20 meter second inverse here. So here for that, A equals to minus g, which is will be minus 10 meter second inverse. V equals to 0 meter second inverse. So if the ball rises to a height y from the point of launch, then using the equation v square equals to v naught square plus 2a y minus y naught, we get v equals to 20 square plus 2 minus 10 y minus y naught. Solving, we get y minus y naught equals to 20 meter. Now for this another one, which will be, we can solve this part of the problem in a two ways. Note carefully that the method being used. So for the second part, it will be used the two method here. The first method is, in the first method we split the path of the two parts like that, the upward motion A to B and downward motion B to C, and calculate the corresponding time t1, time taken t1 and t2. Since the velocity at B is 0, so we have here on the same way it will be v equals to v naught plus 80, which is 0 20 minus 10 t1, and where t1 equals to 2s. Okay, so here for the same, so on your same way, this is the time in going from, that I had told you, from A to B, and or the point of maximum height that the ball freely under the acceleration due to the gravity, and the ball is moving in negative y direction. So we use equation here which has been y equals to y naught plus v naught t equals to half at square, and we have y naught equals to 45, y equals to 0, v naught equals to 0, a equals to minus g, which is equals to minus 10 meter second inverse. So we'll put the value 0 equals to 45 plus half, so minus 10 t2 square. Solving, we get t2 equals to 3 seconds. Therefore, the total time taken by the ball before it hits the ground, so t1 plus t2, for that t1 plus t2 equals to 2s plus 3s equals to 5s here. Okay, now for the second method we'll go for it, and that the second method for this which we have to solve here, that the total time taken that can also be calculated by noting the coordinates of initial and the final positions of the ball with respect to the origin that chosen and using equations. So we go for the same here and we'll be solving it out for the second method. So for the second method here, that is being used for, and that is y equals to y naught plus v naught t plus half at square, which is, now y naught is equals to 25 meter, y equals to 0 meter, v naught equals to 20 meter second inverse, and then a equals to minus 10 meter second inverse square, t equals to the question mark. So it will put the value here, which will get 0 equals to 25 plus 20t plus v2 minus 10t square, or we can say here 5t square minus 20t minus 25 equals to 0. So solving the quadratic equation for the t, we get t equals to 5 seconds. So now we have the second method is better, since do not have to worry about the path of the motion, as the motion is under the constant acceleration. So we'll go for the another one which we'll discuss in the next coming class, in the 22th class. Here we're going to end up with, but before ending it up, we had done your chemistry for class 11 part 1. Part 2 we are dealing. We had done your reasoning, which is verbal reasoning and the non-verbal reasoning. Other than that, we talk about it. So yes, we had done your computer-based numerical and statistical technique, as well as we are dealing with your database management systems as well. After talking about that, coming towards physics part 1 for class 11, we had done your unit chapter 1, that is a physical world, wherein that we had completed your physical world, what is physics, scope and excitement of physics, physics, technology and society, fundamental forces in nature, nature of physical law. And chapter 2 that we had completed is your units and measurement, which is introduction, the international systems of unit, measurement of length, measurement of mass, measurement of time, accuracy, precision and instrument, and the errors in the measurement, significant figures, dimensions of physical quantity, dimensional formula and the dimensional equation, dimension analysis and its application. On the same way, unit 3rd which we had covered up is your motion in a straight line, which is introduction, positions, path length and displacement, average velocity and average speed, instantaneous velocity and speed, acceleration, kinematic equation for the uniformly accelerated motion, which we had even though started with. After that, we will discuss about the relative velocity, and then we'll ending it up with this unit as well. After that, unit 4 we have to complete, that is motion in a plane. Unit 5 which we have here is your laws of motion. Unit 6 is work, energy and power. Unit 7 is your system of particles and rotational motion. Unit 8 is your gravitation. So here we're going to end up with. Thank you, hope you enjoyed this video. If you like this video, please give a thumbs up and give a suggestion on a comment box. Please like, share and subscribe.